these are by weird numbers. They're not like numbered as they should have been. So see how many you got out of, what are they, 10? See how many you got out of 11? And I'm going to talk about the most highly missed ones, okay? So on number 1, we should be fine, right? We can determine oxidation states just as well as anybody. 8, we should have been okay. There's only one acid-base reaction there, and it was the one with acetate ion and the hydronium. Definition of a Bronsted-Lowry acid is what? It does what? Donates a proton, right? H+, and then a Bronsted-Lowry base will do what? Accept a H+. The reaction of the single species oxidized, what happened to the peroxide? What was the oxidation state of O in peroxide? -1, and so then it goes to O2, which is a free element, so it's a zero oxidation state, and then the water had a -2. Those should be like 20-second questions, right? For 21, I just wanted to show you something before I erase this. If anybody is available for tutoring today, tomorrow, or Friday, these poor little ladies need some gas tutoring in Mr. Schmidt's class. Gases. You got this. Ideal gas law. Units. Like, emphasize units. They're in the middle of that right now. And I have, like, graduation speaker meeting today, and then I've got 2 days of training off campus, Thursday and Friday. So I won't see you guys after today. Don't cry. You can. Just do it on your own time. But you guys will take practice exams tomorrow, and then Friday you'll check over that practice exam, and you'll have a little bit of time for your film festival, as well as just a little bit of multiple choice practice. Okay? So, okay. 21. What do you have to start with there? You have one number, right? 1 mole of CO2, right? What you can do is you can combine versus doing 2 stoichs. You can do 1 stoich. So the ratio is 3 moles of CO2 is produced for every how many moles of reactants? 6. So you can do a total of 6 moles of reactant, which is 3 over 6 is 2. It's just a little bit shorter, maybe 20 seconds, but it might be worth your time. How was 25? It wasn't bad, right? Like, really, you have 3.0 times 10 to the 23rd divided by Avogadro's number, which is about what? Half, right? So 3 divided by 6, same exponent system, so half. Then you have half times what? 2 moles of HF over 1 mole of H2. So what's half times 2? 1. And what's 1 times 20? 20. That shouldn't have been that hard, but it's probably intimidating at first. You can balance on 41. 44, who got that right? Oh, like 6 people. Okay, so that's the one where I wanted to show you the way of thinking, just because it looks like it's challenging, and you'll notice some decimal systems here in a second. If you had 1.42 grams of sodium, what was it? Sodium sulfate. It told you the molar mass, right? Right, they're not trying to have you calculate molar mass in the middle problem most of the time. 142. How many moles is that? Okay, so that's 142 and that's 142, but that's a difference of 2 decimals. So then all you have to do is write a 1, but back the decimal up 2 places, that would give you 100th, right? So that's how many moles of sodium sulfate you have. And then separately, you have a hydrate sample of 3.22 grams. Subtract that sodium sulfate that was dehydrated, which was at 1.42 grams. How much water was removed? 1.8 grams of water. Well, that number looks familiar too. They really are not trying to have you work too hard. So if this is how many grams of water you had in the dehydration process, and the molar mass of water is 18, how many moles is that? So this is 18, this is 0.18, so you back the decimal up 1 place, that makes it 0.1 moles. What's the relative ratio between this guy and this guy? 1 to 10. You have if I basically did an empirical formula process divided by 0.01 divided by 0.01, dividing that by 0.01 would be 1, dividing that by 0.01 would be, say again, 10. So X, this is a decahydrate, so X would be 10. All you have to do is look at the ratio of these individual species once you get them to moles. C, you did empirical formula. You did 48 divided by 16, which is what? Which is what? 3, and what's 52 divided about 52? 1. So the ratio should be 1 to 3 for chromium oxide, or chromium 3. Well, yeah, that's not chromium 3 oxide, but it's, we're going to move on. 63, you kind of had to set up a what? Well, I'm proud people, I can't hear you. BDA. So if you have a BDA, that means you technically probably have a limiting reagent problem. How many moles or millimoles of potassium permanganate did you have? Who used moles? Raise your hand. Who used millimoles? One or two people. Okay. I think it's easier to use millimoles here because only, like, the numbers are just a little easier to work with. So 20 milliliters times 0.2 molar. What's 20 times 2? So 40, then back decimal, back 1 because of this right here. That gives you 4 millimoles of potassium permanganate. And same story, you have 50 mils of 0.1 molar sodium oxalate. So 50 times 0.1, 5 millimoles. If you set that up underneath the BCE they provide, and you say, okay, 4 divided by what? That's because it's like 2 permanganates in the balanced chemical equation, and it's 5 oxalates, right, in the balanced chemical equation. So remember our trick for LR is 4 is what I have. I have 2 coefficient here, so 4 divided by 2 is 2. 5 divided by 5 is 1. This one's going to run out first because as I appropriate everything with this ratio, I don't have enough of this in the end. So this is your LR. So it's going to control how much product is made. So as you take your LR, 5 millimoles of oxalate, and you subtract the 5 millimoles, you know that's 0, which that's what the definition of LR is, right? But we're making carbon dioxide, and it starts with 0, but what's the ratio once it reacts? 10 to 5, which ends up being 10 millimoles of. Which is the last one, right? We'll look at that next one for Q. Yep, I'll send right now. Thank you. Bye. Charmium and Ricardum to the front office. That's you guys. I was like, what? Okay. Just take the monkey. Charmium. Yes. No, but as you appropriate your ratios, if you have 4 millimoles of the permanganate and you need a 5 to a 2 ratio of oxalate to permanganate, those 5 millimoles are going to run out before your 4 millimoles do. Because we use our trick most times to our coefficient comparison. This is how much I have of permanganate, but I need a 2 to 5 ratio according to this BCE. I have 5 here, so this is going to run out in one shot. Only 2 of these will be used for every 5 of these, so it's going to leave me leftovers of 2. Okay, on that last one, number 74, I just want to state that was a 6th grade question. That was not a math question. If you got to the point where you're like, oh, I've got, about 1/3 of a mole of glucose, and then it's divided by 0.2500, you saw 4 sig figs all the way. The only answer with 4 sig figs is, well, that makes sense, is C. Okay. All right, so I'm going to wait for them to get back real fast so we can check over FRQs, looking at the V graph now, okay? You can function as an individual or as I might think it's probably the same one. I only have so many things to choose from. All right, we have a different colored pen in hand or device that you're writing with. And I want you to add points or include extra detail where you need to. In terms of a graph like this, it's very abnormal, right? So most of the time when we're doing like a reaction, we're usually doing a titration. And usually the titration we're measuring what? What are we measuring with that titration? pH, right? So the y-axis would be pH. This was different. They were measuring what? Conductivity. So imagine there's like tons of physical properties we could be testing, so don't be scared if you start to see other things like, I don't know, yeah, pH and conductivity. Those are two big ones. Can't think of another one right now, but you could imagine that you could graph something else and then still use the same premise. Any inflection point in the graph is the equivalence point, and you can start to make assumptions at the equivalence point. Any inflection, right? So it's the vertical section of the curve or the V part of this. So the only time we say neutralization is basically when we're having an acid and base react, right? So what's the acidic and basic component of this reaction? Don't say the whole sulfuric acid and barium hydroxide. H plus and hydroxide. This is almost like half reactions, but they are not mentioning it as half reactions. They're just asking for the specific ions formed, okay? And or ions forming the product. And then the precipitation ions, Ba, 2 plus, and sulfate, making barium sulfate. Okay, so your point values came in here with 1 point for each correct product. Okay, so 1 point for water and 1 point for barium sulfate. And then a collective 1 point is earned for the correct reactants with the atoms and charges balanced in both reactions. So like HOH makes H2O, that's balanced. Ba, sulfate, that's balanced. So you have 1 point for each product, 1 point for collectively having all the stuff on the reactant side, right? Right, how many points do we have? If you got all this right, you have 3. No, my bad. That's sometimes confusing. I think this is 3, 1 point for each product. So I'm saying 3 points. Let's go with that, 3 points. Okay. And after this, identify the species that enables the solution to conduct electricity. Shout them out. Barium. Oh, hold up. It can be barium hydroxide because that is not an ion. Barium ion and hydroxide ion, right? Now, that's because that was the excess reagent. So I think you only had to put one of them. Yeah, so you had to only have had one of them. That's just a quick reminder. Strong electrolytes are the ions that are in presence in excess, which is barium 2 plus or hydroxide. Yeah? Yeah, that's not specific enough. Because it says identify, and if it says identify, it's like, give me the exact. Okay? All right, so that's 1 point for those ions. That was the initial information, right? So you have barium hydroxide, and then you titrated in the sulfuric acid. So that's why that's the excess reagent. Next, we have Y. So, like, identified, great. Now, why does the conductivity increase? Short and sweet. JT, what you got? Good. Okay, so that's one, the precipitation reaction. And then the other, everybody? Formation of water. Water is a pure liquid. Pure liquid water It's not going to ionize in appreciable amounts, therefore it does not have any conductivity abilities. So you had to mention it based on the equations you wrote, not on I, because I, you maybe only mentioned one or the other, but the equations you wrote were the parts that definitely identified going from ions to non-ions. So barium ions are removed from precipitation, hydroxide ions are removed from neutralization to make pure water. So 1 point for each correct explanation. So I think that's 2 points too. They get better with their rubrics on defining how to give points. Okay, so if you're trying to calculate molarity, you could have done this in honors chem. What do you have to start with? Taz, when you started. Okay, what was the volume of the acid? 0.5. Can I see a graph? Look at the amount of acid titrated in the y-axis or x-axis. Huh? So I'm going to go with 30. Okay, 30 milliliters of sulfuric acid. Okay, we're doing stoic all the way through. So I'm going to use millis. So stick with millimoles for a second. What's the next step, everybody? So use the molarity to get to moles. What was it? 0.1 millimoles of H2SO4 over 1 milliliter. That milli and milli cancels. Here's where you get a point indicating the moles of acid. Right here. You don't have to stop though. You can proceed. What's the next step? 1-to-1 ratio. 1 millimole of barium hydroxide for every 1 millimole of sulfuric acid. Okay, so then that's like us crossing over using mole ratios. Now we're barium hydroxide. Now how do we get the concentration? So 1, not 1 mole, just 1 is a like placeholder over what? It was only 25 milliliters, correct? Okay. And that was the like initial value provided. So 30 over 25 times 0.1, about 0.12. Is that right? Okay. Okay. So, and that's to correct sig figs. You got a point for 1 point for determining the number of moles of titrant added. Titrant is sulfuric acid. That could be implicit, which is like us doing stoichiometry. That's an implicit point. And then 1 point for the calculation of the original barium hydroxide. 0.12. Okay, how would we approach finding the barium 2+ ion at the equivalence point? What's the approach? KSP. Now, because they provided you, I don't have the question up top, they don't just give you KSP willy-nilly and be like, this is an extra fact, you don't need this. You have to use it. So if they give you something, you are going to use it. There's no trickery here, okay? So if you have the barium sulfate salt that has formed at the equivalence point, that's the only thing present along with water. And that's insoluble, right? But we all know that's not really true. It's slightly, barely soluble. We have a KSP value to show us that. So when you set up an ice table, it makes 2 ions, barium ion, sulfate ion. The ratio is X to X. And when you solve with X to X, using the KSP expression, barium sulfate, that's equal to the KSP value. That's X and X. So essentially you're just doing X squared is equal to 1 times 10 to the negative 10. Square root that 1 times 10 to the negative 5th. So don't think you're not going to use all the data, because you will. Okay? It's another coaching point for you. Just call me Coach Inside. And then after you added over-titrated, added more sulfuric acid, you keep adding sulfate, 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 sulfate. So if you continue to add sulfate, and this equilibrium expression, or equilibrium reaction, you essentially have the common ion effect at play. So barium sulfate is already formed as a solid. It equilibrates to barium 2+ ion and sulfate ion. And if you continue to increase this concentration, it's going to cause a shift where? Everybody, shift left. And as it shifts left, it's going to consume the sulfate, some sulfate that's been added along with the barium ion, decreasing both of their concentrations as you proceed to produce more solid. And there's the phrasing if it helps right there. So read that for a second. And then come and grab your test from yesterday. Fatima, Darcy, Drew, Emily. I have not told them. Cassie. Yours right here. Gigi. Chase. Vicky. Andrew. Carrington. Marcus. Niles. Miriam. Megan. JT. Taz. Margaret. CJ. Jaden. William. Christian. Steve. Alright, can you guys do me a favor? Can you get up and go to a lab station? I need 5 big groups. We're going to try to start by ourselves and then I'm going to follow up. Okay, because I definitely want to go to the last one. 5 big groups, go. 10, 9, 8, you're good. You jump in. Okay. 8, 7, 6, 4, Okay, so listen for me. You have a colorful pen. Now, the copies are a little light because the copy is stupid, but somebody doesn't know anything, you get mine. So I want you to start checking question 1, and then if you have questions on that, we'll talk about them together. But you have to put an underline or a highlight where you literally got the point. There's no you like, oh, I meant that. You wrote it or you didn't. Okay, go. Somebody might be looking at your group. So let everybody see the keys. It helps them see it.
What if we said that they mutually carry the same charge?
This one
Why are they right here? Like, you don't think was this one? If we get one of them.
Guys, I'm rotating. Do you not wait on me to start that one and then go up on the other?
Okay. No, because look, unless well, you have to have them when I order them.
Any question about C1? It says like talk about how they have to be significantly different, but we said how it wouldn't work because of the signs. I do
Sometimes it's hard to get
If they're trying to be in order, or is there something different?
I don't believe
They got those.
Yeah. That's what I'm understanding.
Where's your start now?
Use that stuff really well. I think.
More than me, right?
What?
More than me.
Now the rest of the questions we got.
What did answer?
No, yeah.
Why not? You know that shit for your eye. Yeah. That's just because they question it. Can't take place. Nothing like what. What is that?
Separated into H2.
That's not right.
Well, I was gonna do that, but I was like, no, that's too easy. You gotta do something else. Well, the drum like yeah, I mean, you got the same amount. Yeah, it's just like Otherwise, come on, I got one.
On third game. That one after the
I was also going to say, why not associated?
I'd be better on the
Three out of 8?
I don't know.
Well, we got only 50.
Take about one more minute. Take about one more minute.
Other question. There was one talking about Kansas City. They said, it's for this one. So you're saying like, we're just like Is that the same as like
Okay.
So why would this one like that's not
Alright, come back up here, bring me my answer keys. Come back up here, bring me my answer keys. Let's go. 10, 9, 8, 7.
I do like the arrows representing like the more energy that the gas molecules have. Would that?
I think that's fine.
Okay.
It doesn't interfere with your answer. 8, 5, 4. Not sure I am. 6, 5, 4. Bring my answer keys up here. 3. Thank you. Bring me my answer key. 2. I'm missing 2 more. And 1. I think I got 3. Okay, here's a couple things I need from you. 1, right on the top of your free response, I think there were 10, 10, 4, and 4. So is that right? So is it 28 points? Okay, so out of 28, just for now, what you've done, and if you like have not completed it, then go ahead and put incomplete. I want to finish looking at those. I specifically just want to talk about, I think it was this question. Just give me a heads up on question 4. Just right here in front of your chest. How many points did you get? Because I think there were only 4 points available here, right? Be proud of that big 0, big goose egg, if that's what you got. Okay, so I do hate that you didn't get this one because pretty recent examples we've done. So doesn't matter that you don't know what methyl, guys, hush. It doesn't matter if you don't know what the chemical name is. If you've got a sketch and you've got to have octet on everybody, you can count valence electrons, by golly. And if you don't count valence electrons, shame on you, because that's basically the only way you'll double check at the end and have confidence to move on. So how many valence electrons should this guy have? So 1, 2, 3, plus 4 is 7, plus 6 is 13, plus 4 is, or am I at 13? 17, plus 6 is 17 plus 6 is 23, 24. And so you can double check at the end to make sure it's 24. Also, you know that if there's ever a C hanging off or a C with a O hanging off it, it's got to be double bonded, because there's no other way for carbon to get octet. Carbon will not ever have lone pairs. Like, I'm almost 100% sure that you'll never see on an AP exam, unless they're trying to say, hey, calculate the formal charge of this. It's wrong, because we would never have a lone pair on carbon. Carbon lets just share 4 times. Okay, and then on this one, I saw some struggles yesterday. So you've had your reaction, single or 1-to-1 ratio making a diatomic ethanol molecule. 50% of it has reacted. Could you see my work on there, my little BDA? ICE, BDA, it kind of went both ways here. So if you had ethanol plus ethanol equilibrates to ethanol diatomic, it told you what, 0.2 moles or 0.02 moles? Right? So I combined these because I didn't want to work in 2 separate ways, because this is literally the same compound. So I called it 2 ethanol equilibrates to ethanol diatomic. So that's 0.02 moles, and 50% of it reacts. Well, how much reacts? Come on, guys, other than Queen. 0.01. So you're subtracting 0.01 moles, but when it reacts in a 2-to-1 ratio. I do think it was really helpful for me to see that ratio by combining them. If you didn't, then I would encourage you to try that. Guys in the back with me? Thank you. So if that reacts in a 2-to-1 ratio, and I had 0 of this initially, I'm adding 0.01 in a good 1-to-2 ratio to end up with 0.01 moles here and 0.005 moles here. And that was really the breaking point. Like, okay, I can either go ideal gas law or I can use proportions, because if assuming the temperature and the pressure were unchanging, there's no need to do the ideal gas law unless you just love it and you're like, I have time, I got 20 extra minutes, I'm gonna move on. But this is the mole ratio, or mole quantities, that should be related to the pressure they gave you, which was 0.74. And so what you can do is use basically your own little proportion. Pressure initial, moles initial, which was 0.02. Pressure final, moles final. What's moles final here? Yeah, it's summative, so that's 0.015. Moles total, and you could solve for P2. It's almost like Charles's law or Gay-Lussac's law. It's kind of almost made up, but it's definitely proportional. And then in the last part, because we had moles, it was easy to do a mole fraction for each of those individual components. And the mole fraction multiplied by the total pressure at equilibrium, which is what, 0.56, which is our answer from part I. The mole fractions, then you could then use in your KP expression. Mole fractions with the partial pressure. Yeah. You just carry them down. So you could have, you totally could have found partial pressures in part I, but you had to do ideal gas law twice, right? Which that's just a lot of math for minimal points. So I was like, I shouldn't be doing this much work for a single part of this question. So that's why I went with this. But totally, if you have your ideal gas law, get your partial pressures up top, carry those down low, your points are just going to spread out. Yeah. So when you did P initial over moles initial equals P final, pressure final over moles final, and you're solving for pressure final, you're doing P initial times N moles final over N initial, and that gives you P final, which was 0.56 or 0.55 atmospheres. And so this is at equilibrium. And since it's at equilibrium, we're going to utilize that in the equilibrium expression setup. Hard. I think this was a hard 4-point question. They would just take your math and they carry it through. So no, it wouldn't matter too much. What's up? Scroll down. Yep. So this is, but we probably, if we had our moles initially, we probably would have at least got to mole ratios or mole fractions. But notice there's no points for mole fractions, so you really had to go bigger at home. Okay. All right. So on that one, eventually, just in maybe 5 minutes or less, if you guys will put that in the box so I can see those, see how you did. And we're going to talk through the last FRQ, so go ahead and put your laptops up too, okay? Let's talk it out. Partial pressure. Yep. If you have a total pressure and you've got two gases or some more gases, they're only going to make up a little bit of that total pressure. So that's where my fraction. Can I? What can I also do? I can't really get home. I only have some that I can see. Secure ones. I try not to. I try to. But I can see like you did like here today and Friday, and they're like live in the box. Does that work?
Yeah, thank you. Because I'd rather like practice it. And, like I tried like listen,
You can
but
do it like intervention too.
yeah.
Thank you. Put your laptops up. Oh, did you guys see? I'm sorry. I know. Obviously you saw this, but you guys saw those like intense IMF questions where it was like you only got points if you mentioned like the strength of an LDF. I thought that language in the answer key was really good for you to see, so that hopefully you understand how to explain polarizability. I think I answered all your other questions though.
Anything else we need to talk about?
Can you give me a second? I'm getting ready to review this with the class, okay? I can't make that bigger. Alright, laptops up and then eyes back up here for me. I'm waiting on, I think, 3 more computers.
Hold on.
Alright, come back to me. 3, 2, I have like 5 minutes, I think we can get through most of this. 1. Alright, so you have a reaction. Is it here? You have a reaction, and this reaction is redox, right? So we've got electrochemistry all the way. We have a battery. What kind of battery is that? Looking just at the diagram. Galvanic because it has a cell bridge, okay? Oh, dang it. It also says a galvanic cell. You can't mess up here, okay? So we have a balanced equation. 2 half reactions are shown below. Blah, blah. I want you to discuss which is the cathode half reaction. You have 30 seconds.
Yeah.
Okay, 3, 2, 1, hush. Okay, left hand if it's iron, right hand if it's permanganate. Some of you guys waited a little long there. Okay, so if it's galvanic, what do we know about E cell? Right, if it's galvanic, E cell is positive, and the only way E cell will be positive is if you take a big number for reduction potential minus a smaller number for reduction potential. So who has to be the big number? The permanganate, which is 1.49 volts, minus 0.77 volts. Remember, it's E cathode, which is the wet side of the gas. Again, reduction side of redox minus E anode, which is the oxidation side of redox. And so what's that when you subtract? Yeah, 0.72. I agree with you. I think I do. Yeah, okay. All right, so that answers A and B, right? Calculating the standard cell potential. Which side is, of course, the cathode in this picture? This left and this one's right. Okay, so the right is the cathode. It's drawn like our traditional ones, but do not assume they will always be drawn. They like to switch it up. All right, talk about how you would process C. How many moles of electrons are transferred when 1 mole of permanganate ions are consumed in the overall reaction? All right, you should be done. You're working too hard. It's one conversion. It's just a 1-to-5 ratio. So if you have 1 mole of permanganate and you're trying to get moles of electrons, 1 mole of permanganate is related to 5 moles of electrons, so it's a 1-to-5 ratio. So you do 5 moles of electrons transferred. Do not work too hard. But to get equilibrium constant, what do we need? What's that one law with E cell and K?
Negative R2.
Okay, hold on. I heard delta G is equal to negative NFE, and then I heard what? So delta G is equal to negative Rattling. Okay, so then these two are equal to each other. What's N in this case? 5. So you're just double checking, right? Because it's 5 and 1, and the total mole of electrons would be 5. I think you guys could do all that. What's the R? Ooh, what's the R constant here? 8.3. Ooh, we got the energy one. Okay, Jules died.
What's here talking?
You are working on constructing your project.
So,
What's your topic again?
electron configuration, quantum mechanical model.
That looks good so far. I'll see if I can keep thinking about it. Okay, thanks, dude.